All right, guys. So remember that if you guys were in our entry task and you guys were on time, we have already completed the entry task. I should still see this on your guys' papers as you guys do your notes. If you do not have it there, that means that you guys will be marked down. Now, if you did not come to class today, it is your responsibility to finish these on your own time. So today we're going to start activity 3. It's an introduction to inequalities. So I'm hoping today that you understand what are inequalities and what the meaning of inequalities are. Now, inequalities, I know you guys have covered them before sometime in your mathematical careers. Inequalities are just mathematical symbols used to compare sizes of values of two expressions. So that's exactly what we're doing here. We're comparing values or sizes of values. Now, let's say I have this inequality here, this mathematical symbol. Do you guys remember what side is bigger than the other side? Now, most of you guys probably are remembering or reminiscing on the alligator, right? If it's opening up an alligator, it looks like an alligator's mouth, it's always going to eat the bigger pile. So you could automatically see an inequality and see which side is bigger because it's always going to be opening up to the bigger. Now, when something's bigger, I don't want you to say bigger. Let's get more mathematical vocab with it. That means that this side is greater than this side. Now, of course, I'm not going to say this side, right? That means I want you to be able to see both ways too. If the left side is greater than the right side, that means the right side is less than. So, of course, the numbers are going to depend, but if the inequality is true, it's always going to work out that way. All right, so let's go to our second one. I notice that my inequality is opening up to the right. That means that the right side is greater than the left side. Or if I want to flip it up on me, like at least my thought process, I know that the left side is less than the right side. So again, make sure that you train your mind to see both of these. Now notice that the bottom two are a little bit different, but for the most part, they are the same. What I mean by the same is that if you notice your inequality is opening up to the left, that means that the left is greater than the right. Now, that means that the right is also less than. Now, there is a little difference that you have to take into account, that there is another option that's possible. Whenever you see that line, it may also be equal to. So that's why we want to read these symbols as, okay, if I'm reading it from left to right, this side is greater than or equal to the other side. And same thing when it comes to our other symbol over here. You just got to be careful and make sure you understand what side is bigger. So I see my inequality is opening up to the right. So I know that the right is greater than the left side. Well, that also means that the left side is less than the right side. And now notice that line's underneath, so that means that it could also be equal to. So I know you guys are familiar with these. Let's make sure that we understand them completely. Now, what I want you to do is I want you to check if the following inequalities are true. Now, just because an equality is written down doesn't mean that it's actually true. It doesn't mean it holds true. It could be a false inequality. Now, it is your job to test the following 4. Now, this is the way I want you guys to do it. Now, notice that there's an inequality right over here. There are 2 sides of an inequality. This inequality is telling me that the left side is greater than or equal to the right side. Now, it is your job to check if that is true. Now, in order to figure out what both sides are, you need to use your orders of operations, your PEMDAS, each and every single time. So let's go ahead and start doing that. I'm looking to the left side. Are there any work to be done inside the parentheses? And the answer is no. So you don't have to worry about the work inside the parentheses. There are no exponents, but there is multiplication. 5 times 3 is a positive 15. Notice that you're still going to add the 2, and it should be greater than or equal to 12, or at least you're testing to see if it is. Now, we're almost done. There's no more multiplication, no more division, but there is addition. Now, I want you to do these steps. Some students can do this in their head, but I want to see every single step. 15 plus 2 is a positive 17, and that supposedly is greater than or equal to 12. Now, is this a true statement? Is 17 greater than or equal to 12? Yeah, it's greater than, right? The alligator would eat the greater side of 17, so that means that this is true, the true inequality. Let's try the next one here. I'm going to change colors so that way things don't get mixed up. So I have 2 sides. Notice I have an inequality where my left side is less than my right side, or I'm going to test to see if that's true. Now, looking at my left side, there is work to be done inside the parentheses in this problem. I could do 5 plus 8. 5 plus 8 is 13. So I end up with negative 2 times 13. I accidentally wrote a negative there. Just ignore that. So 2 times 13 is less than 1. I'm going to write that because I don't like the way that came out. There we go. A little bit better. So now that I notice that there's no more work to be done in the parentheses, there is no exponents, but there is multiplication. Negative 2 times 13 is a negative 26. Now, is this a true statement? Is negative 26 less than 1? And the answer is yes. So this inequality also holds true. Now, I think the next problem is probably going to be one that is not, but I have to show my work. I want to see these steps. I want to see a complete statement towards the end in order to get both points. So let's do this last one. Let me erase my little list here so that way I'm not confused. So I have a left side and a right side of my inequality. I need to check if the left side is less than or equal to the right side. So let's go ahead and do that. Now, I always like to simplify one side at a time. So 5 plus 6, notice it's just plus, so that's a pretty easy one, is just 11. But now I have to figure out everything on the right side. Now, there's no work to be done inside the parentheses or no exponents, but there is multiplication. 3 times negative 5 is a negative 15. Don't forget the plus 1. And now I can finish up. Negative 15 plus 1 is a negative 14. Now, always ask yourself, is my alligator facing the right way? Is that alligator eating the bigger number? Now, is negative 14 greater than 11? And the answer is no, it is not. So that inequality doesn't hold true. It's a false statement. It's lying to you. All right, so let's finish up and do this number 4. So a lot of the same. I'm going to check to see if the left side is greater than the right side. So let's do the math. Looking, there's no work to be done in parentheses, no exponents, but there is multiplication. Negative 2 times 10 is a negative 20 minus 5. We're checking to see if it's greater than a negative 25. Now, a negative 20 minus 5 is a negative 25. And that should be greater than negative 25. Now, is this a true statement? Is negative 25 greater than negative 25? And the answer is no, it's a false statement. If we would have had our equal sign there in our original problem, then that would have been a true. But unfortunately for us, it is not true. So that is how you check to see if a inequality is a true statement. Now, sometimes it's true, sometimes it's not. Now we're going to start to check to see with substitution and a little more of that kind of stuff. So we're going to let this load, and then we will go from there. All right, so this is where we left off. We're going to check to see if negative 5 is a solution for the following inequalities. So when I look at number 1 here, I notice I have x plus 12 is greater than 7. Now, I don't know what x is. I don't know if it's what it's a solution, but I'm going to check to see if negative 5 is. Now, why did I choose negative 5? Because that is what the directions told me. I'm going to plug in, I'm going to substitute negative 5 in for x. So instead of writing x this time, I'm going to write a negative 5. And then I'm going to add 12 to see if it's greater than 7. Now, I want to see the step. I want to see you substituting before you start actually testing it, just like the problems we did up here. So remember your rules of PEMDAS, no parentheses, no exponents, multiplication, division, there's only addition. Negative 5 plus 12 is a positive 7. Now, is 7 greater than 7? And the answer is no, this is a false solution. So, is negative 5 a solution to this inequality? No, it's not. Let's check to see if it is on our other inequality right over here. So all I'm doing is I'm going to plug in a negative 5 everywhere I have a variable. This time it's a p, but I'm not going to let that distract me. 1 minus 2 times whatever p is, and I'm putting in a parentheses so that way I can see what I'm plugging in there. Negative 5 is less than or equal to negative 9. Now, just like before, follow your rules of PEMDAS. Is there any work to be done in the parentheses? No. Is there any exponents? Nope. Multiplication? Yes. You have negative 2 times a negative 5, which is a positive 10. Now you're checking to see if that's less than or equal to negative 9. 1 plus 10 is 11, which is less than or equal to a negative 9. Now, once you get to this point, you have to analyze it. Is 11 less than or equal to a negative 9? And the answer is no. So that means that negative 5 is also not a solution to that inequality as well. All right, so just to change it up, because I want you guys to notice that they might ask you different things for different equations. For instance, is negative 10 a solution to these two inequalities? Well, we have to take our time and check. we have x divided by 5 plus 1 is less than 1. Now what is x again? It's a negative 10. It's still going to be divided by 5, added by 1, and we're going to check to see if it's less than 1. Now remember PEMDAS. Is there any work to be done inside parentheses? No. Any exponents? How about multiplication or division? Now there is division because negative 10 divided by 5 is a negative 2, plus 1 is, check to see if it's less than 1. Now negative 2 plus 1 is a negative 1. Now have I arrived to a true or false statement? Negative 1 is less than 1. That is true, yes. So that means that negative 10 is a solution. It's a solution that makes this inequality true. All right, one more and we'll be done. So negative 10 is still the same one, same directions. So I have negative 5 times y. Remember, if there's no symbol in the middle, it's times. I show times with parentheses. Negative 10 plus 1 is less than another y, which is still negative 10. And we're checking to see if the left side is less than the right side. So again, I like to do one thing at a time. So I'm going to figure out what everything to my right side is. Now the only thing I can see is multiplication first. Negative 5 times negative 10 is a positive 50. Plus 1 is 51. Now I'm checking to see if that is less than the right side. Negative 10 plus 1 is a negative 9. So I'm all the way done, so I'm just going to write negative 9 all the way down. Now this is a true or a false statement. 51 is not less than negative 9, so that means that this is not a solution. No, it's no solution. And that's all I want you guys to pretty much do for today. Again, reminder, you have to show your guys' work. If you're not showing these steps and simplifying fully, unfortunately, I will have to mark you down. I want to make sure you understand PEMDAS and what you're doing in order to figure out whether these inequalities are true.